Welcome to Unit 3, the core data mining and KDD process. Guys, write this down. This is the most heavily weighted conceptual and scoring unit for the entire semester. If Unit 1 and 2 were about where and how we store the data, Unit 3 is about how we unleash the advanced mathematics and mechanical machine learning algorithms to dig deep into the storage vault and pull out the pure business wealth. Examiners absolutely love this unit because it blends data engineering with the core concepts. So in this section, we are going to master the absolute step-by-step data pre-processing phases, in which we'll discuss about the cleaning, integration, and we'll also talk about the transformation and reduction in detail. And then we'll talk about the Apriori algorithm and the association rule mining with the complete numerical, in which you will be able to understand the concept clearly. And then we'll discuss about the legendary KDD, that is knowledge discovery in database. It is the ultimate 7-step roadmap from raw data to brilliant insights. We'll also understand the difference between classification and clustering and the features that underlie the logic. Alright, now let's get started. Let's start with the absolute basics. What is data mining? Imagine you are sitting on the top of a mountain of millions of raw transactions, of customer logs and text file. To a normal human, it looks like a mountain of digital trash. But to a data miner, that mountain contains hidden gold. Data mining is the automated process of exploring massive, complex data set to extract hidden, previously unknown, I repeat, previously unknown and actionable patterns. So it is used today by every single industry. So data mining is process of extracting insight from large amount of data by using various techniques such as statistical, computational techniques. So the data can be structured, it can be semi-structured, it can be unstructured, right? And it can be stored in different forms, and it is still used to mine the data and create that to take out that hidden gold from the digital trash. So primary goal is to discover these hidden patterns and relationship in the data. So you would see that data mining is used in marketing, like it helps segment customers, and it is also used in finance to detect the credit card frauds before the transaction even completes. And it also used by the platform like YouTube and Netflix to map out the exactly what video will keep your eyes glued to the screen next, right? And it is also used in healthcare to identify the risk factors and for diseases and develop the personalized treatment plan. So data mining is very, very crucial in today's world. So there are few ethical consideration to data mining as well, like ethical and privacy concern, particularly when it involves the personal and sensitive data about the user. And it is also important to ensure that data mining is conducted ethically with appropriate safeguards to protect the privacy of individual and to protect that there is no misuse of the data. There are few disadvantages and advantages. So advantages of data mining are that it assists in predicting future trends, and it contributes in making important decisions for the organizations by providing the data, providing the valuable information from the data, and also to unlock the unexpected patterns while assisting the companies to optimize their production, right? And there are few disadvantages associated as well, like sometimes we can have inaccurate data. So if we don't have the right data, obviously the output, the insight will also be not right. and then there can be security issues, there can be lack of security, which could lead to put the data at huge risk, and data may contain private customer details which can be leaked and misused by the people. And there is also cost and effort associated with the data mining. So excessive work intensity is required by the teams to work on the data mining process. Now, here is a guaranteed question that almost hits every single time. Explain the KDD process in detail. So you see somewhere it is written about what is the process of data mining or the knowledge discovery in database, and I think there are few more names to it. But listen closely. Data mining is not the whole story. Data mining is actually just one single step inside a much larger iterative framework called KDD. Alright, so this KDD, this knowledge discovery in database, is the entire construction line that takes the raw database dirt, refines it into pure knowledge. Alright, so when you draw the this diagram on your answer sheet, make sure that it is chronological steps perfectly mentioned and every step is defined clearly. Okay, so KDD refers to the complete process. So it is a complete process from start to end to discover the valuable knowledge from the data set. So what happens in the process? It starts with the relevant data selection, followed by pre-processing, okay, and then transformation, and then mining. This is mining. So it is the part of the KDD process. Data mining is part of the KDD process, and after mining we conclude the interpretation and evaluation, and then figure out the knowledge which we have discovered from this process. Alright, so it is widely utilized in ML, machine learning, pattern recognition, statistics, AI, and also data visualization. So KDD process is iterative. Iterative means it goes in loop, and if there is refinement, we go back again, refine the process, and then we move forward. It is not like a waterfall model that it cannot come back. You cannot come back from a step. It's not like that. You can always come back to a very first step as well if there is any refinement, any problem occurring, and start again. So now we'll discuss about this step. So this diagram is very important. You need to visualize, you need to jot down, or whatever you would like, take a screenshot, but in the answer of KDD you need to make this diagram as well. So the very first step of KDD is to understanding the requirements. So before you write the code, you must know the business goal. Are you trying to predict stock market drop, or are you trying to figure out why the retail customers are abandoning their shopping carts? What is the reason? What is the requirement? It is very important to understand the application domain, what you want to do, right? So one should know if they are going to describe the data or predict the information, right? So that is how you actually get to know which data you want to target, like what data you want to select, right? So second step is data selection. So you don't mine the entire enterprise disk, you isolate a representative subset or a sample of data that matches your specific target area. So based on your requirement, what data you need, you target that specific data. That comes under data selection. Alright, so that is the very first thing. You select the data from the entire data warehouse or all the data sources which matches your target area. Alright, then we have the third step, that is data cleaning, the scrubbing part. So when you take out the target data, then comes data pre-processing, data cleaning. Okay, so this is where you eliminate the background noise, you remove duplicate record, you strip out the irrelevant attributes, and you handle the missing value. So if your input data is dirty, your final insight will be complete garbage as well. So it is very important that data is cleaned properly. Okay, And then comes the data transformation and reduction. So in data transformation, you convert the clean data into uniform format that is suitable for your analytical math that you will apply forward. So this involves normalization, scaling down variables using dimensionality reduction. So in dimensionality reduction, you are reducing the columns, unnecessary columns which are not required for your processing, right? And then converting the continuous numbers into discrete buckets. This is data discretization. We'll discuss about this later. Okay, so what you are doing, you are converting the data into format which is suitable, right? You see over here, this is data transformation, and when the data is transformed, then we move towards data mining. This is the actual performance. Okay, data mining is the performance engine. It is the heart of the machine. You choose your specific analytical task, what you want to perform on data. You want to perform classification, clustering, you want to perform association rule mining. We'll discuss all this, don't worry. So you let an algorithm run wild over the prepared data to extract the underlying mathematical patterns. Okay, so we use a particular algorithm based on the requirement. Again, what our objective is, what we are finding. You should have a clear goal, and according to that goal you apply the particular mining technique. All right, and then after the data mining, after applying the mining, you are able to get the patterns. So what happens, you go and evaluate and interpret the results. Okay, so once the algorithm spits out patterns, we have the patterns, the human analyst inspect them. So they ask question, are these rules actually useful, or did the model just discover something obvious? Okay, was it something which we didn't knew, right? So because KDD is iterative, that means you can always go back and do it again. If the result is poor, what do, you loop back, you go back to cleaning. Maybe there was problem in cleaning, maybe there was problem in transformation. So you hook back to where you want to, and then you refine the setup, and then you move forward again. Then we have knowledge consolidation. You see the last part is the knowledge consolidation. This is the final step. This is the final victory lap. You take the highly complex mathematical pattern and you translate them into simple, stunning visual graph, chart or something like that, so that the business managers can take immediate revenue driven action. So this is how our complete knowledge discovery works. Okay, I hope you are able to understand. So examiners love to test if you know the terrain, if you know the basics, right? So they will ask, mention the name of databases and repositories where data mining can be performed, or they will simply ask what kind of data can be mined. So you don't just write about databases, you write about these 8 type of domains in which data mining can be performed. So very first kind of data is the flat files. So you see, flat files are simple, they're unstructured text, or you can say they are CSV files as well, in the basis of rows and columns. So this is the absolute playground for research level data analysis, right? You see flat files everywhere. There's so much data in flat files, and you can see CSV text file and scientific data records being part of this as well. Then the second, you have relational databases. Okay, so a slightly more structured format, like structured table managed by SQL tools like MySQL or Oracle. So they are perfect for mining traditional transactional profiles, you see. Okay, so there is clearly a good structured data when we aim for RDBMS, and you see example like banking system or customer databases. The next type of data that can be mined is from data warehouses. So data warehouses, as we know, is the centralized multi-dimensional repository, right? And it contains the integrated historical and subject-oriented data. I hope you are able to understand the meaning of every keyword used in this definition. If you are not able to, please go back to unit 1 and then revise again. Okay, so we can use data warehouses as well. Then we have the transaction data. Okay, so this is the highly specialized logs tracking purchasing buckets with explicit transaction IDs and item sets, and the exact fuel used for market basket analysis, which we'll discuss about later. What is market basket analysis? So we can also use transactional data. So data, this can be mined as well. So transaction data examples such as ATM, online shopping systems, these are example of transaction data. Then we have multimedia databases. So multimedia, it hold multiple types of data like images, files, audio, videos. Okay, and this require advanced computer vision and digital signal processing models to mine the data. Okay, for example, YouTube databases, you have multiple kinds of, so it is the multimedia database. This can be mined as well. And then we have spatial database. Spatial is the repository that is storing geographic location based data, like you see GIS maps like Google Maps. So it is crucial for analyzing traffic congestion or urban development. So when that is our objective, we use spatial databases. Then we also have time series databases. So when you need chronological, time dependent, continuous data like stock market tickers or live weather monitoring devices, and so these kind of data is used, it is excellent for forecasting, right? So when you are analyzing real time data, you go for time series databases. Another, we have World Wide Web. So the internet itself, right? Of course, there's so much data. So this breaks down into web content mining. So what we are doing, we are reading data from web page. So there is web structure mining as well, in which we are analyzing how pages hyperlink together. Alright, so there is so much data, and we can also do web mining as well. So these are the kind of data that can be mined. Now we'll discuss about data mining task. Think about it this way. Once you have your beautiful data warehouse cleaned and packed with data, what kind of secrets can your algorithm actually pull out of it? Examiners absolutely love to ask you to list and explain these core data mining tasks. So instead of just memorizing, you can actually understand how these tasks actually work in real life. So we'll take an example of how a movie streaming app analyzes its user to maximize the profit. Okay, so remember this thing that we will be using this example. So the very first type of task is the characterization, right? So characterization means like you are actually summarizing the general features. Okay, example. So you are having a streaming app, right? You own a streaming app and you want to know who are the ultra loyal users who watch more than 30 movies in a month. You want to know this. So the algorithm, that is characterization, what it does is it scans the database, it roll up the data using OLAP operation, which we have discussed, and it spits out the summary. So the summary says that they are mostly college students and they age between 18 to 24, who logged in after 11 p.m. and love sci-fi. So this was the summary which we took out using the OLAP operation. So what we did, we just generalized, like we summarized the general features of the target class. So our target class was the ultra loyal users who were watching more than 30 movies. So these were our target class, right? And we got the summary out of characterization. So we get the high level description of data using characterization. I hope you understood this thing. And next is the discrimination. So discrimination is actually, it compares the characteristics of target class with the contrasting class. So obviously in characterization we were just doing generalizing the target class feature. But what if instead of just profiling the high movie watchers, we compare them directly against our low activity users? Okay, so for example, we are comparing the target class, that is people watching over 30 movies a month, right? And we compare directly with the people who are watching even less than 5 movies a month. So this is the discrimination. So what happens is that this algorithm generates a discriminant rule. So this discriminant rule shows that heavy watchers use the mobile app on limited plans, for example, right? And the low activity users are just logging on the desktop from their home Wi-Fi. So now your business knows how to separate the two groups, how to know that who are actually using it more and how are they using. So that is, it helps to identify the major difference between the two groups, like I just discussed. Okay, so the number 3 is the massive exam favorite, that is association analysis, and we'll discuss about the example, numerical example for this in detail later on. But right now, being a data mining task, we'll just have an overview of what association analysis is. So it is also known as market basket analysis. You should know this, right? And association analysis discover the relationship among the items that are frequently occurring together. Okay, that are frequently, you can say, bought together. For example, you own a retail store, right? And you want to know which combination of items are bought together the most, so that you can put them together in your shelf and it boosts the sale, right? So that is why you use association analysis. And if I give you the example for the streaming app, so for example, you know that teenagers who users who stream gaming videos have 55% of probability of ordering soft drinks and popcorn. So how do you know this, that they have the probability of ordering soft drinks and popcorn? This is what you take out using association analysis. So here we use this formula, okay, where P is having a relationship with Q, and there are two parameters where S stands for support. So support is how often these items show up together in the whole database, and confidence, it indicates that if a customer buys, suppose, this P item, then what is the exact percentage probability that they will grab the Q item as well. Okay, so this is how we discover the association analysis, and we'll discuss it in detail. Next we have is classification. So the point number 4, classification. So think of it as a digital sorting. Okay, so classification is like it involves the training data with class labels. So we already know our data, right? So for example, we feed the algorithm historical training data that is already labeled. Okay, labeled means that there are already columns to our data, right? And what our algorithm does is it learns the pattern, whatever pattern our data is following, and builds a model. Now what is happening, if there is new data coming up, we already have the predefined label to it, and according to the pattern we'll just assign that to them. Okay, so there are already predefined boxes, and we just assign the new data into those boxes. For example, when a user applies for credit line on our app, okay, so the classification model instantly tag them into one of the 3 predefined categories. That is, either it will be safe, either it will be risky, or it will be very risky for a loan or credit approval. So we already have these predefined labels, and we are just whatever data is coming, whatever customer is coming, we are just using the data and training it in the model and just assigning one of the 3 labels, which is done by classification. So this is the supervised, but we also have unsupervised classification. In this, what we are doing is there we don't know about the labels. Like you see here, we are classifying it into the 3 types, but here the predefined labels are unknown. So whatever data is coming, according to what is the pattern, we are assigning them the new labels. Alright, so what here the objective is to maximize the intra-class similarity. So it is not important that everything belongs to those three boxes as well. Alright, so for example, grouping the customer based on the purchasing behavior, income or interest. So they are completely different from each other. Task 5 is prediction. So what this prediction means? While classification sorts the data into categorical buckets, prediction act as your mathematical crystal ball. Okay, so what it does is, what the crystal ball usually do, it estimates how the future is, like it predicts the future, right? So that is how prediction works. It estimates the future continuous numbers, that what could happen. Alright, so it deep dives into the historical data warehouse and it finds the major answer to the financial questions which apply to the future. Okay, so it is forecasting future values and trends which are or unknown data, right? And what it is doing, it is using the historical data. So for example, we have to predict the sales. For example, you own an e-commerce brand and it is using past growth matrices to predict exactly how much net profit or sales revenue they will generate in the next quarter year. Okay, so how would you get to know that how much will you generate the next? So based on the past historical data, based on the patterns that our data is following of the sales, you are able to predict that how much the sales you are going to make. Similarly, we have number 6, that is clustering. So clustering is like twin brother of classification. So but there's a massive twist. So in clustering, what we do is this means that we have no predefined labels, no training data. So we just dump a massive pile of raw user data on algorithm lab and say that find a pattern. So clustering is always unsupervised. It is always unsupervised. Okay, there is no defined labels over here. So what happens over here is that based on the pattern, we are creating clusters. For example, considering the streaming app you have, you are creating the clusters based on the behavior of the user. Like there are three groups of cluster you see. One is pink, one is purple and one is yellow. So one is considering the late night binger, like late night binge watching. One is casual anime fan, or one is weekend sport viewer. So this is how you cluster the behaviors. So this is how clustering works. So it is like classification, but it is not like classification. Then we have outlier analysis. So the point 7, outlier analysis, is also known as anomaly detection. So in data mining, there are few weird data points that are usually dropped as background noise. So some of the data points that are extremely high or extremely low to the other existing data points. Like you see in this, these are all the data points in the data, but there is one data point that is extremely high and which is not resonating with other things. So but in outlier analysis, the weird data point is the price. Alright guys, let's tackle an absolute giant, another important question that shows up in almost every paper. That is data preprocessing and its major step. Alright, I already told you that the data in real world is completely filthy, right? It consists of missing values, random typing errors, and if you feed this raw data directly into advanced machine learning algorithm, then what happens? The result will be pure garbage. That is why data preprocessing is the most critical checkpoint. Okay, it is the most important step in the entire KDD and data mining process. So let's break down these golden steps of preprocessing. So data preprocessing, first step is the data cleaning. As the name suggests, it is very important to detect and correct if there is any missing data, if there is any outlier, nosy data, inconsistent data in our data set. We often get this incomplete and inaccurate information all the time. So it affects the data mining if we are not able to clean the data, right? So there are few problems that are completely occurring again and again. We get missing values all the time. So there are few attributes that are completely absent for few of the values. What you do in that scenario, if we do not clean the data and send it like this, what will happen? It will create inaccurate insights, right? That is why it is very important to handle such data. These are the type of problem. Then we get the nosy data that contains random errors and incorrect value. If you see a person age written 250, it is not possible, right? It might be 25, or he or she might have entered it wrong. So this kind of data, outliers, this kind of data also affect if we not clean them. Then we have inconsistent data, which is like conflicting information. So if the same customer recorded with two different addresses in our records, then which one should we consider, right? So it becomes irrelevant, it becomes inconsistent. So there are few techniques that is used to handle the data cleaning. So first is the handling missing values. So it is very important that either we manually fill these values, or we use the average. We use average of mean or median or mode to fill up the values which are not existing, right? And we can also predict the values using machine learning algorithm depending upon our data set. Then we can use noise removal method. So in this method, we are using the techniques such as smoothing, binning, clustering regression to remove all the outliers and such data which does not belong in our data set. Then we also have removing duplicate data technique, in which we are identifying the repeated records, right? We can use the SQL function of distinct to identify how many distinct records are there, duplicate records are there. So we are actually working on the data to identify, to reading our data and understanding if there are some records like a customer entered multiple times. So we are able to delete them, we are able to remove them, so that our data is consistent, our data is reliable for processing. So our second step is the data integration. As we have already talked about what data integration is, and it is an important part of data warehousing. But you see, in data pre-processing, it is very important that we combine the data which is coming from multiple heterogeneous sources into one single unified repository. And why do we do that? Why do we need data integration? You would see that when we have a data from multiple sources, multiple departments, there are many speed bumps. Like you would see that if a sales department have a table of data, they have named a column customer ID, right? And if you go to finance department, they will also have the data, but they would have named it as cust_number. So this is the naming conflict, and such things often exist in real world, and it is very important that we integrate this thing, that we are able to combine all the kind of data into one single unified view, so that it is used for accurate insights, right? So integration helps to create this view. So what are the problems? First is schema integration. Like I told you, customer ID, and another it is cust number. So this is the schema integration problem, that different names are used for different databases. Then obviously naming conflict, different name for the same attribute, right? So you would see that one it is customer name, other it would be CUST_name. So there are naming conflicts, right? And then there is data redundancy as well. Same information may appear multiple times, all right, which is very wrong, right? It will affect the insights. So what are the technique used? First, you read the data, you happen to identify the entity, which are the major entity, right? And then redundancy removal. So wherever you see that there are multiple records occurring, same records is occurring multiple times, what you do, you read the data, you understand its importance, and then you take the step of redundancy removal accordingly, we do metadata management. Okay, we deploy metadata management to improve the system, that these separate names point to the exact same real world, right? And we also do data merging wherever required. The very next step is the third step, that is data transformation. Okay, so step number 3, data transformation. So this converts your clean data into the exact format your mining algorithm loves. So till now what we did, we clean the data, we just integrated the data. Wherever there is name changing, we are changing the name. Wherever there is redundancy, repeated data, we are removing that, and we are creating one unified view. Now it is very important to transform the data. Okay, so it converts the data into the suitable format. For example, our machine learning algorithm requires something which is not present in our data, so we add those things or we change the format. So objective is to improve the efficiency, is to normalize the data, aggregate the data, and smooth if any noisy data is present, right? So there are few techniques for data transformation. The first is normalization. So normalization is scaling down giant numerical variables so they fit into a tight uniform range. For example, converting raw exam marks into decimal percentage scale, right? For example, you want to convert like 0 to 1, okay, and you want to convert it into -1 -1.0 to 1.0. So this is a scale, you are giving it a scale, and all the data is particularly in this scale only. So this is how normalization works. We are normalizing the data, we are giving them range, right? Next we have aggregation. So it is combining raw granular data units into a summary form. Okay, we are aggregating the data, summing it to see what is the overall view of our data set, right? So for example, we have daily sales, okay, Monday 200, Tuesday 500. So and now we want to see monthly how much happened in the month of May. So that is how we use the aggregation function. So next we have generalization. So in generalization, we are replacing the low level details with high level concepts. Like we are converting the raw city inputs, which we have Delhi into an overarching country code like India. So we are converting all the Delhi in our Delhi and all the cities which are existing in our column into India. So we are generalizing it, we are going to a high level concept. All right, then we have attribute construction. So creating a brand new data column by combining the existing one. Okay, so if for example you are combining the user's age and income to create a unique metric called customer spender category. All right, so you are combining the age and income to see what age people are spending how much or earning how much, right? So this is how we are able to construct an attribute according to the needs of our algorithms or our requirement of business, right? Next is data reduction. Okay, so this is the data compress engine. So when you work at an enterprise level, your data warehouse hold petabytes of record, like so many record, right? And running data mining model on a data set that that requires massive and crazy computational cost, and it also take many days. That is why it is very important to shrink the data, to reduce the volume of the data, right? And while maintaining the integrity, we are making sure that the essence of the data is not lost. All right, so it is very important we shrink the size, and the goal is to obtain the smaller data set with the similar mining results, so the insights is not affected by the data reduction. So there are few techniques that are used for data reduction. First is data cube aggregation. So it is used to summarize the record. We use OLAP cube over here and we aggregate, we summarize the data. Then we have dimensionality reduction. So in dimensionality reduction, we are dropping the useless or redundant feature column. So whichever column in our data set is not required, completely irrelevant, but we have it in our data, so it is just acquiring the storage, right? And it will take more time in processing. So we reduce the dimensionality, we reduce the columns which are not required by our data set, by our machine learning algorithm, all right, which do not have any essence. Now let's look at your foundational concept, that is, what are the various technologies that come together to power the data mining. So it is a very easy concept, so we'll go through it very quickly. So we are talking about the 5 pillars, and there are more to it, right? So you can research accordingly. So first is the database technology. Database technology, why do we need it in data mining? Obviously we need to store the data. You can't mine the data if you don't have a fast, efficient place to store and retrieve the data, right? So that is why we need databases such as RDBMS, data warehouses, transactional databases, so that we can perform the efficient working on that, so that we are able to store and retrieve millions of records seamlessly. Second kind of technology is statistics, the mathematical brain, right? So the second pillar, statistic, is the mathematical backbone of data mining. So statistics help us to calculate data analysis, probability, and all of the things which are required to evaluate our data, right? To identify the trends. So without statistical math, we won't be able to validate whether the discovered pattern is a real business trend or just a random coincidence. So it is very important to have statistical techniques which are used to find the correlations, patterns, and relationships. The third pillar is the machine learning. So the automated pattern hunter, the machine learning, it is the heart of our engine. So machine learning provides the algorithms which learn automatically from the data and identify the patterns and improve the predictions. So you look, actual algorithms allow system to look at a data set. They learn from the past record automatically and builds a model to sort or group future entries without being explicitly hard coded again. So this is what the power of modern enterprise is like. You see Amazon, Netflix recommendation system, right? So it is working on already existing, they have trained it, and now your data is just fed into that system and it automatically provides you the recommendations, right? So this is how actually things work. Then we have the fourth pillar, that is artificial intelligence. So while machine learning focuses on data patterns, AI provides the overarching cognitive framework for intelligent reasoning. So what is happening, we are having a good level of high level automation over here to identify the patterns. So it's what allow data mining system to act like human experts, such as automated banking shield, which is instantly recognizing and freezing a complex credit card fraud, right? So it is very important to have such intelligent system integrated, so that we have a cognitive judge, right, which is helping us throughout the time, which is helping us to discover the hidden knowledge from complex data set, and it helps the machine learning algorithm. So it is not something that works independently, it is all integrated, right? Next we have data warehousing. So obviously we need a place where we store our data perfectly integrated, non-volatile, and where our historical baselines are not removed, right? So data warehousing also serves as a multi-dimensional data cube. Okay, it support OLAP and business intelligence. So it is very important from a data mining perspective to have data warehousing as an important part of a pillar. So there you have it. These are the 5 important technology that is used in data mining. So there are programming languages you can add into this as well. There are other technologies as well, so you should research as well. Now let's move forward and discuss about classification and clustering. So before we hit the technical definition, let's look at a quick story to burn this concept into your brain forever. Alright, so imagine It's the first day of college, and the professor walks into a massive hall packed with 500 new students. So, first, we'll talk about the classification approach, right? So, the professor has a roster sheet which he or she was given from the administrative department. So the sheet says that these 200 students belong to the computer science department, then there are further 200 students that belong to mechanical department, and 100 more students that belong to electrical department. So the labels are already decided, right? The three labels are already decided. The professor's job is to simply read the traits of any new student walking through the door and sort them into the predefined buckets. So they are already predefined three departments and we are just sorting them in them, right? So then we talk about the clustering approach. So now imagine the same 500 students are sitting in a canteen during lunch. So there are no rosters, no labels, no teachers. Naturally, over an hour, what happens that students start grouping up their own. How? Based on similarity. Like cricket fans sit on the one table, alright. Gamer group on the other corner, guitar players on the around the another table. So they have naturally formed the groups based on the hidden patterns, on the similarity, without anyone giving them a label beforehand, right? So this is the entire game, guys. Classification is the structured classroom, whereas clustering is the organic canteen. So you see over here, classification is supervised learning. There are already branches, there are already buckets predefined. Here we don't have any buckets. So here we predict the known categories. Either it will be this or either it will be that. But here we are discovering the hidden patterns. We are discovering the similarity. We are reading the behaviors, right? Example is the email filtering, spam, not spam. Here you see market segmentation according to the behavior. Who is the most loyal customer, who is the most least loyal, who is just coming and going again and again. So we are using marketing segmentation over here, right? So we have discrete predefined labels. Here we group labels are generated. So for example, I told you about the canteen idea. So the groups were generated automatically according to the similar behaviors, right? Now we'll discuss about the classic benchmark of data science, that is the iris dataset. So iris dataset is just like the hello world of a programming languages. Like we understand and learn to write hello world as the first program, the iris dataset works exactly the same. So it was introduced by a British person, that was a statistician and a biologist, Ronald Fisher. Alright, and it is widely used as beginner friendly benchmark for testing machine learning algorithms and data mining techniques. So why do we use iris dataset? Because it is very small, it is clean and perfectly balanced, and it contains total 150 rows, and each 50 rows are divided into 3 flower species. So these are the 3 target classes, the 3 species of iris flower, that is Setosa, versicolor and virginica. Okay, and then we have 4 numeric values, 4 numeric columns, that is sepal width, sepal length, petal width and petal length. So you see over here in detail, this is the sepal, right? So this is the sepal width and sepal length, and then there is petal width and petal length. So this is the 4 columns which are included, and it is measured in centimeters. So you see over here, this is the data set. So you have sepal length, you have sepal width, you have petal length, petal width and the species according to the data set. So why do we use it in data warehousing and data mining? What is the reason? First is classification benchmarking. So because the target classes are clearly labeled, like there are 3 target classes, so it acts as a perfect playground for testing classification. Because classification, we have the clearly defined buckets, right? So it is best for testing classification algorithm like decision tree, like k nearest neighbor and support vector machine. Then it is also important for pattern recognition and clustering. since we see that iris setosa, when you will download the data, when you will read, you will see that the setosa is linearly separable. Okay, and it is able, you are able to separate them with the two other species, but you will see the versicolor and virginica will slightly overlap with each other when you visualize them. Alright, so this makes it a fantastic test case for unsupervised clustering. Okay, when you want to see when you want to find the patterns without the label, so we can also work it under clustering. Then it is also used for data warehousing ETL testing. So in data warehousing environment, developers can use clean dataset like iris to quickly identify the mock OLAP operations. Okay, to quickly identify how these are working. So it lets them test their ETL. It lets them test how the extract, transform and load data pipeline work, and it helps to visualize the data boards without worrying about the missing or corrupt data. Alright, so you don't have to worry about data cleaning again and again if you are testing it. Now let's pivot to a completely different data mining technique, that is association rule mining. So unlike classification, what happens in classification, which we predict a label, right? And association rule mining looks to uncover the interesting relationship and connections. Okay, so we are finding the hidden connection, or if there is any co-occurrence between the variable in a massive data set. So the most famous application is market basket analysis, aka market basket analysis. So it is famous real world application for retailers. So it helps the retailer to understand the buyer behavior by finding the frequently bought item. So which items frequently end up in the same shopping cart. So this is how they'll able to identify the frequently bought item together, and will be able to increase the sale by strategically placing them closer, right? And this will boost the sales. So first let us first talk about the three key matrices which we want to know to understand the working of association rule mining. So it is written as this, which stands to if A then B. Okay, so this is how we write the association rule, if A then B. So the first matrix is support. So this measures how popular an item set is. Okay, so it is simply the proportion of total transaction that contains both item A and item B. So you see over here, support if A then B, transaction containing A and B and the total transaction. So for example, there is beer and bread. So they are total they are bought 5 times and there are total 10 transactions. So we'll get the answer of support, right? And then we have confidence. Confidence is how this measure how reliable the rule is. So given that the item A is purchased, how often does the item B also appear? Okay, so we want to see that how much is the reliability, how reliable is the support. Okay, so we write it confidence if A then B, transaction containing both A and B, and transaction containing only A. So next in the line is lift. So lift measures how much more likely an item B is to be bought because the customer bought item A. So here we are comparing the B's generosity. Okay, we are comparing B's general popularity in terms of A. So what is the lift A then B is, we use the formula of support, the calculated support of A then B upon support A into support B. So this is how we calculate the lift. And if the items are highly associated, then lift is greater than 1. So whenever we get lift that is greater than 1, if we get it 2, right? So that means the item A and item B are highly associated. That means there is a positive correlation. And if the lift is equal to 1, then items are independent. They are entirely independent. And if it is less than 1, that means they are substitutes. They are opposites. Means that buying A makes them less likely to buy B. Alright. So these are the three matrices upon which the association rule mining is calculated. So you need to understand this as well. So the a priori property says that if an item set is frequent, then all of its subset must also be frequent, right? If item A is bought most frequently, then all the items which are bought with A might be frequent as well, right? Conversely, in the opposite, if an item set is infrequent, then all of the superset, right, all of the superset might be infrequent as well. For example, item B is the most infrequently bought item, like it is the least likely item to be bought. So the item B, whenever it is associated with someone, then might be that superset is not that much bought. Okay, I hope you're getting my point. So let's understand this in detail. Okay, so walk through example. So let's say we own a small grocery store. Okay, we own a grocery store. Now when we talk about data, so we have a data, you see over here, where we have transaction IDs and there are the item bought together. All right, and we are given some thresholds. Okay, so we are given that minimum support is 40%. So since we have 5 transactions, 40% of 5 means the item set must appear at least 2 transactions to be considered frequent. Okay, so this is the threshold we are given, and the minimum confidence given is 70%. So the confidence and support both are given to us. It's 40% and 70%. So now the very first step is to generate first item set. Okay, so we count how many times each individual item appears across 5 sections. We count. Okay, so first we see bread. So bread is bought 1, 2, okay, then 3 and 4 times. Bread is bought 4 times. If we talk about milk 1, 2, 3, 4. Milk is bought 4 times. So you need to check that every item at least appear more than 2 transactions. Okay, more than 2. And why are we saying that? Because we are given the support of 40%. So 40% mean that item must appear in at least 2 transactions. Okay, so here you see we have bread 4, milk 4 times, diaper 4 times, beer 3 times and egg 1. So this would not be considered. We cannot keep it. All right. And the very next step is to now what we have bread, milk, diaper, beer and cola. Egg is eliminated. The step 2 is to generate 2 item sets. Okay, now we'll generate the pair. We'll pair up the remaining items of 2 and count how they appear together. So we paired first bread and milk. Okay, so bread and milk, if you count, see, bread and milk first. Here we have milk, we don't have bread. We have bread and milk, we have bread and milk. So bread and milk is occurring 3 times, right? So this is how we create, we count it, and it is greater than 2, so we'll keep it. Similarly, we do it for bread, diaper. It is also coming 3 times, we'll keep it. So bread and cola, and you see beer and cola. These are not occurring greater than 2 or at least 2. So they are just occurring 1 time. So what we'll do, we will eliminate these 2. So these are, because they are failed to meet the minimum support count, that is 2, right? So these would be pruned, these would be eliminated. Now similarly, we'll create 3 item sets. So we'll create the pair of 3. So now we are left with bread, milk, diaper, beer and cola. All right, so now bread, milk, diaper, bread, diaper, beer, milk, diaper, beer and milk, diaper, cola. So we'll create all the 3 pairs that are unique. Okay, now all of these have support of maximum 2. If you calculate, if you check in this data set, you will see that bread, milk, diaper occurs together 2 times. Similarly for all of these. So what happens, we keep all of them. And if we try 4 item set, what will we get? We don't need the meet the minimum support threshold, because we already got 2. And if you create 4 pair of 4, no one would get the count greater than 2, because it ends over here, right? Every pair over here equals to 2. So that is why we won't generate the 4 item set. So this is where we stop. And now what we do, we calculate the confidence. Confidence is calculated by count of A and B upon count A. So first we calculate the confidence for bread, diaper and then beer. Okay, so we calculate for this. Now you see the count of bread, diaper, beer and upon the count of bread and diaper. So when we do this, we get 2 by 3, that is 66%. And if we have below, since the confidence is 70%, and we get here the confidence of this relation as 66.6%, therefore we reject it. Now rule 2, it is bread, beer and then diaper. Okay, now we'll similarly have count of bread, beer and diaper, that is 2, and count of bread, beer, that is also 2. So you see we get 100% acceptance rate. Okay, so this would be accepted. Then the third rule is diaper, beer and then bread. Now if you calculate it, it will also get the 66%, which will reject. So you see there is only rule 2 we accept, that if bread and beer bought together, then diaper is always bought together. Alright, so this is our conclusion, that our mining data system successfully found the strong rule, that is if bread and beer bought together, then diaper is also bought. So if the customer walks to the register with bread and beer, the store owner should expect them to buy diapers as well. Okay, so what a store manager should do, he or she should place the diaper right between the bread aisle and the beer cooler to maximize the sale. This is how we use association rule mining by the retailers to understand what is the relationship between the frequently bought item set. Okay, I hope you understood. Alright everyone, that brings us to the end of unit 3. Up to this point, we have covered all the heavy core mechanics of data mining, especially how the a priori algorithm operates as well. So you need to pause this video here and now, and you need to try all these PYQ radars yourself. Try to write down all the keywords according to the question, and also research yourself if you're not able to find the answer in my video, and make sure that you're able to answer each and every question by researching or by recalling yourself. All the best, and let's move forward to unit 4.